Okay, so good morning. Thank you all for attending this talk. Today, I'll be presenting to you some challenges that the Splunk GDI department had regarding the infra management, building labs for developers and testers, and how a component-based approach is helping the teams. But first, let me introduce a little bit. So I am Brazilian. I'm living in Krakow for the last 3 years. Although I'm Brazilian, I have no skills playing football. Currently, I'm a SRE at Splunk. I started my careers about 14 years ago. I started as a front-end developer. 2 years later, I became a back-end developer and I start to work with infra and cloud. And since then, I never stepped a foot outside automation or cloud. I have experience working with storage, monitoring, security, and networking. Splunk. For those that don't know Splunk, Splunk is a software platform to search, analyze, and visualize machine-generated data. And inside Splunk, we have many departments. One of these departments is GDI. That means getting data in. And this department is responsible for building products, tools, technologies to bring data from a large number of system products into Splunk. And technical add-ons is one of these products, and they are also named TA. That connect many third-party data source into Splunk. The TA has one specific kind of development cycle. So first, the product manager come to the team or one of the teams, and based in this market strategy, give us a new version to work. So he say we have a new version, new product to work, or a new update the current TA we have for one specific product. Once we get the requirement, we need to understand how many versions of this product we have to support, and which Splunk platforms we need to support. And based in these requirements, we build the labs. So the labs will be, a number of the labs will be a number of product versions times the types of setups and configurations. So let's think 3 different versions of one product that we need to support times 2 different kind of setups for this product. So this will be 6 different labs that developer must create, and that 6 different labs that developer also must create to a specific kind of performance testing, other kind of testing. So in this, people use some scripts to make this automation, or they use some previous snapshot as base image and make some manual configuration, because there are a big number of permutation of small configurations. And in these 2 steps, the people spend a lot of time making this process and less time coding. And this is a problem because we need more time spent in coding so we can deliver more value to the customer. That is the parsing, the extractions, and other things that is good for the customer. So in response to this challenge, we came up with 3 different ideas. That let's use infra as a code, but the first approach we tried was to implement infra as a code in each one of the TAs. That's nice because we start to use Terraform and Ansible for that. They are open source tooling for infra management. Terraform is quite commonly used for cloud to manage cloud provider resource such as AWS, Azure, Google Cloud Platform. Ansible also is common to use to automation, configuration management, application deployment, and other kind of IT process. Using these tools, you can reduce the pain creating labs, avoid duplicates, so the developer don't need to create anything from scratch, only reuse that was created before. And if the TA is changed to a new team in each kind of cycle, still have reliable and constant lab across all dev cycles. The problem, we have small teams, and they should be more focused in the TA development than in the rather than creating infra as a code or end labs. So, and also putting the infra as a code per TA, we have a lot of copy and paste because there are some common configurations. And if there are a bug, it's hard to scale because you have to fix in one TA and copy and paste to another TA. And also because the things are small, as I mentioned, demands to know infra as a code. And because this tool is more common used for DevOps or SREs, there are a gap using this approach. So we tried the second approach. So Splunk already provides this open source tooling, Splunk Attack Range. This tool provides an environment that you can create vulnerable instrumented environments to simulate attacks and collect all data and send to Splunk. So it's good because you use infra as a code, support some case that we already need. The problem, everything is static configuration and don't allow parallel labs. So if you need, let's say, 5 different deployment of Linux, one SUSE, one Debian, one Red Hat, Ubuntu, and something else. So it will be 5 different deploys. We have to create one file, configure this file and deploy, and destroy the environment, change the file, and so on, until we have all labs that we need. Or create 5 different space. That's hard because you have to manage 5 different space, and that's a problem. So we came up with a different approach. So to use a component-based approach. So as React.js, that's everything's a component, and you can pass parameters and get returns. We use this idea using infra as a code. The requirements to make possible, we need to deploy everything under the hood using infra as a code. Should allow customized labs and also parallel labs. So I could have as many environments with specific configurations as I need. For the components that the framework will be supporting, the user don't need to touch any infra as a code, only creating abstract layer for that. And also enable to the developer to manage the lab's life cycle. So he decides when to create the lab, when to destroy the lab, when to start the machines, when to stop the machines, and other results. So with that in mind, we create an internal framework, lab builder, that use Terraform and Ansible to manage the lab, creating the lab and make the providing of resources inside each EC2 machine. We are using AWS, but because everything is a component, we can easily extend to work with Azure, Google Cloud Platform, or other kind of cloud provider that is supported by Terraform. The Terraform, the scripts are used to create the EC2 resource, EC2 instance, and all the AWS resources. So everything that the lab needs, like security groups, the subnets, and other resources. After the EC2 machine is created, each one of the machines is created, the Terraform calls a proper Ansible playbook to make the provisioning of the systems, like install software, making configurations. And once it's done, you have your lab running. And from the user perspective, the unique input is a file describing the environment. How should it look like the environment? So the file is this pseudo.json is using HashiCorp language as input, and everything is a component, I say. So one lab is a component, so you can have as many labs you want, and each one will be a component. As I say, the lab is component. Each component has parameters. In this case, the lab has parameters like the type of the lab and the list of nodes that we have in this lab. And the node also is a component. that has his own parameters and a group of roles. And a role represents the feature that you want to install or make the configurations inside the this EC2 machine, and also has parameters. For example, let's say you want to install a specific software, and you want to say, I want in the version 1, and in another node, you decide to you would like to have the version 2. So that's why you have these parameters. And also you have the block OS that you decide here which distro and version you want. Let's say Windows 2018, 16 or 19, or Ubuntu 20, Debian 11. So you decide the version and the distro that you want for this node. Here we have the whole vision, how to like one machine inside one lab. And so based in this template and this file that the user fill, the framework knows what should be installed in each one of the EC2 machines and in each one of the labs. So one environment type in this framework represents a predefined kind of relation between the nodes. So one node, one low node standalone is using like standalone type. But let's say some kind of hierarchy, one domain controller for Windows, and there are some members that is in the same domain controller. This is a different kind of relation. So you have to create this kind of predefined relation, and you say which role you are providing for that. We'll see later in this presentation. And another type is a specific role in this environment, as I say, could be in the domain controller, a domain controller, or the same member. But talk ship, show me the code, as Linus Torvalds say. So the framework is internal, but I created a demo. So you can, if you want to see later after presentation, you can call on and yourself. It's very functional. Here I implement the concept, because more important idea of this is the concept using a component-based approach to build this lab. That's the code itself, because the code that you represent what you need for your lab or for your deployment. So now let's go to the code. I created a Docker compose, and everything that is necessary to run the Docker, to run the lab, is inside this Docker. So the terraform, the ansible, and all toolings we are shipping inside this Docker. And if you want to run yourself, you can check the README, and here's the saying the requirements, what you need, for example, Docker Engine and Docker Compose. But we have everything running. I had also my credentials to AWS. So let's see the file as is in the here. So I have this file, input.tf-vars. So this is my configuration file. Let's say I'm deploying the region US West 1. My lab, you have this prefix name, and my environment name will be my env, but could be anything that you want. So it could be my env 01, and I have in the same level my env 02, and so on. So as many labs I need, and for each lab, as many nodes I need. In this case, it's just one machine and one lab. So here I'm saying I want to use the Linux standalone. It's a predefined environment, and I want to use the role Linux in this environment, and also install this dummy role that I encoded here. Just true, this is the parameter, and this will be installed in a Linux Ubuntu 20 in the size T2 medium in the AWS. So if I decide to use something different, I could say 18, Ubuntu 18 and other size, or could be a Debian 11, SUSE 15, something different. And once you fill this file, you are ready to go. So we have this make and a command. So this is the work to the developer. So he don't need to care anymore about coding Terraform or Ansible. So done. Let's see. This will take a few minutes to download the dependency and make the deployment, while we can see the code itself. So this make file has this make lab deploy, and then lab deploy will run this command here. So this is represented. So in this case, the Terraform is applying this folder here. So what will you have in this folder? So in this folder, we have the state of the Terraform plus a few scripts in Terraform. So in this case, this wire represents, as the name say, wire. So it's all supported kind of environments that I need will be here as a module. And I'm using this local to filter. So if I have Linux standalone as in my input file, this variable will be filled. And for each item in this list, I'll be interacting and calling this module, environment Linux standalone. In case of Windows, would be Windows. Or if I need something different that is environments, I need to create a new component and support this in this wire. So let's see what's happening. So we are passing here some configurations regarding from the input file. So, and the name of the environment and the deployment configs like security group and other constants that we need to do this lab. And in this environment, we also are filtering the role Linux. Remember from the file, we have the Linux standalone, that's the environment type, and the Linux, that is the node type. So this is the node. We are filtering the node, and we are putting all items here in this server. Once we have the server, this variable filled, we are interacting for each item and calling this module, distros Linux server. Also passing some parameters that we need to code. Remember the OS, distro, and version. So here in this constants module, we have the list of all distros with versions that we support. We can see here. So constants. So here we are supporting, in this case, Linux and Windows. And for Linux, we have Suzy. This is the owner from the AWS account. And this is the user that we log on. And the Ragasp that we find in the Amazon search. Same for other here. So remember from the, so we were in the environment. Let's see now the distro. So the distro is actually the module that will create the EC2 machine. So everything is a component, as I say. So the environment is a component, and the distro is also a component. So you can use different environments and reuse the same module that is this Linux distro. And based in the configuration, the parameters that you pass, we create the proper EC2 machine. So getting the proper image, the size type, the subnet, the SSH key, and the security groups. And once the machine is running, this will be executed. That means, okay, just information that the machine is booted, and we are ready to go. And the terraform will call this no resource and command that we execute this command, provide command here, and you can see what's inside this variable. It's a string with the ansible playbook, the IP that will be generated from this deployment, plus the place where is the file. So this playbook represents also a component. So all Linux will call this playbook Linux. But the roles that we installed inside this playbook will depend of the parameters that we pass in the configuration file. So we have this extraverse with the information about the neighbor roles and other stuff that we pass. So now let's see the Linux playbook. So here, in this case, it's just 2, but we could have as many ones. So this is just for the demonstration. I just included 2. And remember, in the config file, we have only this one enabled. That means this Linux functionality 02 should not be executed and not executing anything inside. So not creating or downloading or installing anything that is supposed to do. Only the 01. And how this is possible? Very simple. So in this case, the framework is using this when. So we can use enable roles when it's defined. So this is just a simple definition. So you can increase this logical with more parameters. Let's say if could be the version is 1 or the version is the 2 or something else. So based in this conditional, I'm saying, okay, import this module. So this I'm defining the listed component that is the role. So the role is a component. The playbook, that's a group of roles. That's also a component, and that's used by the Terraform distro module. That also a component, and the environment module is also a component using a list of distros. And so you have this lab that's a component, and you're using the configuration file as many components you want. So this is the simple logic. So it's not rocket science. So here, let's see if the deployment went. So finish. Simple. So we can see here, in this case, that my task 02 was skipped because I did want it, and the 01 was worked. So change it. And we can see here, getting this helper, and you can see inside what was done in the machine. So first, let me show you the test, what was done. So simple, just echo in a file, but could be anything. Could be download the one software, install the software, load some default configuration, restart the machine, and you can create as many tasks as you want. And here you can include as many files you want, so you can split the configuration in different files. So it could be something like that. So it could be and on. So this is very simple. So here is my machine. Here is the IP. Will not work. So don't try to access this machine because it will not work properly. First, because this IP is blocked, and second, because you don't have the pen key to access if you're trying to hack this machine. Here, as I mentioned, so this is the task. We can see the task was created and done. I have the machine. So let's see in case that I want to include a new feature in this machine in this lab. So I can do that by open this file and so okay. Yeah. So now I'd like to run the EC2 in the EC2 machine. this role as well. So down here and make lab deploy again. So now we are updating the lab, and this will install the second task that you need to do. So we can see we take a few minutes again, about 2 minutes, and we can see more about the code. So let's see here. I create a second file with more complex environment. So in this environment, I have still one environment, unique environment. Okay, here. So it's a unique environment. In this case, I'm saying that I'd like to install a third functionality. Will not work because I don't support this functionality. Also here, a second functionality, the same configuration, just a different name of machine. Here would be a third machine with different version and just one functionality. And this will be also a different version with a different functionality that will not work because we don't have this functionality. In case we want to support a new component, that is this case, we have to code this component. So in this case, we need to create a new role and wire inside the playbook. So we need to do something like that. We should come here and say, now we're supporting this name, and we need to go over here. And you see there are two folders. So I should create a new folder, and the structure should be this with tasks, and inside the task as many tasks I want with the main and the same conditional or something similar that we did for the links functionality 01 and 02. So this is how you can create new roles and support new components. And same for the Terraform. So if you like to support, let's say now, the BSD or the macOS or something else that we need support, so we can go back here. Okay, finished. So let's change the machine, just update the providing, so we are not losing the machine, and we can see here was created the task 02. So done. I have the task 02. So this task, that is a doc file, could be installing, for example, one software, another installing a second software, make some configuration, and that's how you can create standalone components, and they can be plugged together in the same EC2 machine. And let's see. So I have some points here. So let me show you how to create a new distro, how it's possible in using this component. So in this case, we need to go to farm, modules, and see. I created a BSD server, and we can enter here. We have some Terraform files and done. So here we have to code proper Terraform file and call the proper playbook. So you need to create also a playbook for this component if you want to run something there, right? And done. This is how you can create for this BSD. Let's say you want to do something with macOS. In case AWS, to run macOS, you need a physical machine there. So you should create a proper Terraform script to create this create the parameter of ask to AWS reserve a bare metal for you, and inside this bare metal you install the macOS. So you need to create a proper block of Terraform code here to make this request. So the Terraform is abstract to the user. So everything that you must do inside doesn't matter to the user. So you have to do whatever is necessary to run the component that you need. So this is the great point. So same for environment. So once we created the module here, the distros, but we are not executing anything. So we need to use some demo like the aim. So let's use this range that I have here that will represent the environment. So in the environment, let me open. So first, higher name. So you can see here, I created, as I mentioned in the beginning, about some Windows domain controller. So here I will show you about this environment. So if the user pass one environment with this type, this environment, Windows domain controller, that means I will be interacting here in the Windows domain controller, and for each one of the environments, I'm calling this module, Windows domain controller. So let's see what's happening inside this Windows domain controller. We have modules, environments, Windows domain controller, and here we have the main, output, and variables. Let's use API. So same. In this case, I mentioned about the roles. So in this environment, we need two roles. One is for domain controller, the head of the environment, and the nodes. So here we have the nodes. So doesn't matter how many domain controllers you pass or how many members you pass. You just have to mention that, okay, in my node 1 is a domain controller. In my node 2 is a server member, but he is the head of the server member is the node 1. So you have to pass this in the configuration file to link this. So here we have the module. Okay, cool. We have this this guy is calling this domain controller. You can see it's the same distro. So the role inside the environment doesn't matter because in the end it's the same vanilla distro. So I can reuse as many I needed. So if I need a third role here, I could create, and that you will use the distro Windows server, I could use, or even use a Linux server here in my environment because I'm using LDAP server with domain controller and make some configuration that you need a specific configuration. So it doesn't matter for the user, just matter that he must pass some parameters, and the Terraform and the Ansible will know how to handle these parameters and make and create the environment. That's the greatest point in this framework, is helping to the developers to create the labs they needed based in components that we support. So in case that we don't support one specific distro or role or environment, well, in this case, one person must do code, but once it's coded, everyone else can use this framework to build this new component. So this is the great point in the presentation. So the code itself is not important, right? So just the idea. So I came to here to present this approach that we have that was very, very important to our department and how we are fixing some issues regarding the spending time creating labs. Now, in a few minutes, we can have labs running well configured that we need for our development. So let's back to the PPT. So where to find me? So if you want to ask me some questions regarding presentation or regarding anything else, please, you can contact me on LinkedIn. You can see my repos in GitHub. You can send me a DM on Twitter. Not so how much yet, but we'll see in the future. And thank you. Let's back to the studio and see if we have some questions.